It says that Stanley's Investments is trying to lure Gunther away from retirement tactics, where he currently earns $90,000 annually. So again, when we're starting these problems, we want to first identify what kind of situation are we in. Anytime they're talking about taking an employee away from his other job to come work for us, that's a moral hazard question. So we know we're going to have a participation constraint, which says, come work hard at our job, it'll be better than your other job. And we're going to have a selection constraint, which says, working hard at our job is going to be better than shirking at our job. And we know that we're going to look for some signal to pay him either a high wage or a low wage. In this case, the signal is success. They could have said high profit. They could have said a lot of things. But in this case, it's success, and they say that with hard effort, there's a 75% chance of success. So notice in this question, they don't tell us with low effort the chance of success. So they gave us F, which is the chance of success with high effort, to be 0.75. They didn't give us G. G was the chance of high profit with low effort. When they don't give it to us, we assume that it's 0. They tell us that if you come work for us, your disutility of effort is going to be 100. So they tell us the cost of that hard effort, but they don't tell us the cost of the low effort. So again, we're going to assume that it's 0. If you don't work hard for us, it's going to cost you 0 in disutility. The question says, how much will Stanley's offer to pay Gunther if he accepts Stanley's offer and is then successful? So from that question, we need to figure out what are they asking us to solve for, and it's WH. Because if we are in fact successful, that's the signal that we need to pay him the high wage. So if it said and is then unsuccessful, we'd be looking for WL. But we're looking for WH, and let's go ahead and write our constraints. So again, the participation constraint is going to say, working hard at our job, well, you'll have a 75% chance of making that high wage and getting the utility of the high wage, 25% chance of getting the utility of the low wage, minus the 100 that it costs you to work hard, and we're going to set that equal to your reservation utility. Now real quick, they gave us $90,000 as his reservation wage. They could have just given us $1,200 as his reservation utility, but we had to do that extra step and plug in the reservation wage into his utility function. So just make sure you understand that they gave us his actual dollar amount that he's making, which is the reservation wage. They could have given us just his utility at his other job, and we'll see that in other problems. In either case, it's pretty simple to deal with. So now let's take a look at the selection constraint. What's going to be identical on the left side? It's still going to be working hard at our job, but now on the right side, we know that G, we assume, is going to be 0, so for 100% certainty, we're going to make that low wage. So we're going to have the utility of our low wage. And again, the cost of that effort we're going to assume is 0 again. So from those constraints, what we notice is the left sides are identical. Both this left side and this left side are identical, so the right sides must also be equal. So WL we can conclude is $90,000. We can then go back into our participation constraint and plug in WL to solve for WH, because WH is what the question asks us for. We do some math and combine like terms, and we can solve for WH in this case to be $111,111.11.